Hi there. Today we will be talking about unions. Union is something which is very similar to structures. Structures have fields, they are aggregate, bringing together of some known data types. So are unions. So just to remember a structure, let's say AAA has a field of, let's say, integers x, another integer y, and a float a. When you look at the memory organization of this, you see that by definition you have two fields for x and y that can accommodate integers, and a field that has a subfield that has a name A, which comes after x and y. Just an example. So AAA is of this structure. AAA is something like this. When you create a variable of structure AAA type, then you have a variable that has two integer fields and a float. Yes, we had a minor correction in this, that it is possible in some computer architectures that here, at the boundaries, you may have unused additional bytes. So we call them alignment bytes. So the total size of the structure is at least the size of an integer plus the size of an integer, that means two integers and a float. If we switch over to a union and keep everything the same, same fields, integer x, integer y, float a, the memory organization changes. This time, it is memory organization of AAA, and this is the memory organization of BB. You have the same size of an x, then you have on the same position another one y, and a. So let's the difference is the start position of a field in a structure is the end of the previous field. So wherever x ends, y starts. Even sometimes there are alignment bytes, additional alignment bytes in there. For the moment, forget about that. So x ends, y starts, y ends, a starts. Here, all are pushed up and start from the beginning. X starts from the beginning of BB, Y starts from there, A starts from there. They overlap. The first moment when one hears this says this is totally nonsense. Why shall I use this? For example, you have a variable in this terms, union BBB, just a name to it, S, and you store S some number. Here goes in the internal representation of 475. If you switch over to SA, what is SA? SA is something strange. Let's say if it has 8 bytes, such an internal representation, the first 4 bytes are the bytes that are coming from 475. The remaining bytes, these are garbage, and you cannot get out neither the floating point representation of 475, neither something sensible, actually, if you do not access that field with a type that is compatible with this one. If it's integer, then integer. As a chance, if you would use the y field, you will get your hands on 475. But if this would be something else, let's say long integer, then again you would be in trouble. You would have a strange entity sitting over there. Now, why shall we use such a overlapping pushed up structure? At the first sight, it doesn't make any sense. For a single moment, I want you to think of Excel, Microsoft spreadsheet program Excel. What do we have over there? Well, it is something like a matrix. You have columns and rows, and at a column, let's say D7, yes, D7, you can store some data. What can that data be? It can be a formula. It can be integers. It can be a date. It can be a floating point. It can be some string. For example, a room numbers, a room code, a street name, an address, whatever you like. All can go in here. You can change it also. Now, for a sec, think that you are the engineer that has to implement a spreadsheet, the Excel. Not use the Excel. Write the program of Excel. Well, first of all, we have to solve the general layout problem. If you want to do it very primitively, without any insertion or deletion, then you would choose a static two-dimensional representation. Two-dimensional, so sheet would be something by something. Let's say 100 by 100 something. What would you put over here? What would the type of it be? You cannot say it should be integer. You cannot say it should be floating point. You don't know it. The guy who is going to use your program at the runtime will determine to fill in some data in here. So, you cannot say much about it yet. Of course, for each of these, there would be some internal data type. For example, formula would be presumably a child pointer, the formula, or some pointer to an internal representation of the formula, an integer, a date, possibly a structure or an array, integers, or integer of 3, something like this. A float would be usually a double. A string would be a child pointer. All of these have different sizes. The worst would be either the double or, it would either or the three-dimensional integer array for the date. But you don't know which one it is. One way as a programmer would be manually go and find the largest one of these, use that one, so you would be on the safe side if you don't store anything like that in there. But you have always that amount of place, and then you use pointer arithmetic to change the way you access that field. Presumably you would do a malloc for each of these, or something like this, and then while you are storing an integer, you would get the pointer to that specific box, change the pointer type, dereference it, and use it to store something in there. Union does it for you. The purpose is this. You want to say, I am not sure at the moment of compilation what I'm going to store in there. It can be one of many. So you tell each element is union BDD, for example. Then, when it comes to store, let's say, an integer, you put on your integer glasses by using the appropriate subfield identifier and access it. So let's do it for the real problem of an Excel sheet. So, I'm defining a union for the Excel element as it can be a formula or even something, some other type that is defined, then a long integer for the integer, then for the date, and then for the floating point number, let's choose a double. And for the string, these are basically all the possibilities that can go into an Excel cell. So, when I'm sorry for that. So, this static allocation will be done at compile time. It will give me 10,000 positions, each having a union as an element. What is the size of the union in this case? What is the size of the union? Size of a union is the maximum over all subfields of the union, maximum of all subfields. This has a size, this has another size, this has another size. You take the largest one. The largest one becomes the size of the union. Now, when runtime comes and the user has entered a string in there, you detect that it is a string and you use presumably through a case statement or an if statement, you decide to use to store a string over there. So you perform a malloc and you store in sheet something 17, 5, a position in here, right? Some string, just for the moment, let's say you have had for example, if you have prior done a malloc of some size, For the moment, don't think about how do we do the malloc, etc. for the string reading. That is not today's problem. Today's problem is reading, for example, various formats in and storing them into the union box in there. If you would have read an integer, let's say, and scanf you got integers. By the way, we said long integers, so it should be LD. To store that into, oh sorry, here I made a mistake. String. Sorry for that. Now I want to store integers into, let's say, sheet 17, 6, integer I. So the way to access it with an eyeglass is simple. Simply you use one of these subfields, so that field becomes, sheet 17.5 becomes a variable that holds a string. Because they are not of the same size, some of the bytes may left empty. That is not our concern. The problem is we are able to store in a single position, let's say, various types depending on our decision. The decision that we make at runtime. Now the only problem left here is, let's say the user has entered various data in the Excel sheet, you read it, you stored it into the box, then you go, he has gone down and this time entered an integer in there. It's okay, you detect that it is an integer, you use this time the integer subfield and store in there the integer. All these are okay. You can use any of these. But later, when the sheet is somehow full and you come to a cell, how will you remember what eyeglass have you put on while storing it in there? Is it an integer sitting over there? Or is it a floating point? Or is it a character pointer? Or is it a formula pointer? What was it? Somehow you must keep track of this. First comer to C have always a difficulty in understanding this. The C system allows you to use the union is just a way to store various types in the same position making the decision at runtime. It doesn't keep track of what you have used. Have you used the integer subfield to store it in, or have you used a string to store in a pointer? Nobody is keeping track of it. So when I come back to, let's say, 17.5, there is some data, and how will I know what is sitting in there? It is my sole responsibility to keep track of it. It is my duty to keep it. Well, how can I do that? Well, various methods. You can make a list. You can make a shadow matrix. So, parallel to this, what is the smallest possible data? It's a char type. It's a 1 byte integer. Char. Okay, something like this, the same size. And when I have stored sheet 17.5 in the matrix with a string, then I run to my sheet cell info array, some other array, and do sheet cell info 17.5 and store something which later on reminds me that there is a string store. So I make myself a list memo to myself. If it is a formula, then just pick any number, right? Please don't pick 0. That has some problems. Some number, 42. Then integer, some other number, 75. If it's a date, then another number, 77. Floating point, 88. String, 101. There is no logic behind the numbers that you have chosen, right? It is just, the only thing is that from this set to this set there should be a one-to-one mapping, right? So later on, when you see the 101, you will be able to say, aha, it was a string. Nothing else. This 101 doesn't have any other relevance than just being a sticker. Then here you store, what was it? A string, 101. Tells me later that here sits a string. And in this following example, you would presumably use sheet cell info 17 6 integer, what 75, okay? 75 tells me that it is an integer. Later on, I will have somewhere in my code possibly a switch statement which looks at the sheet cell info I, J, and has here some case which says if it is 42, it is a formula. Deal it as formula. And it goes down to case string 101 deal it as string. That means use sheet cell info ij dot string. That makes sense. What if you make a mistake? We make such mistakes, you run in trouble. It is quite possible to store in there the integer and then refer there as a floating point, and you have a stupid floating point sitting over there on your screen. So very carefully you must keep track of what you have stored in there. Just remember, any time you deal with union, there is no way that the C system tells you which way you have accessed the union. By this way, or this way, there is no mechanism where you can go and look at the data and discover that, oh, this is a string pointer. It's a char pointer, it's a string. There is no way. So you make yourself a note about it. One way to make a note is this. Next, now we have a short break. In the following lecture, we will see another alternative to keep track of it. But again and again, I want to repeat myself. There is no mechanism to tell later on which way the union was accessed. It is there some data sitting. You have the right to put any eyeglass on it. An eyeglass is choosing one of the subfields. You put an eyeglass on it and you interpret those bytes in there as, let's say, a day or a floating point. A common mistake students make is that assuming when I store an integer in there and put on later on the floating point eyeglass, I will get the floating point representation out of the integer, or the string representation of the integer. Does a conversion for you? Nobody knows what you have stored in there. It's only you that will know that you have stored there an integer and no auto conversion or something like that takes place, right? Yes, now we have a short break and continue in a second.